In this video, we'll discuss this question from GATE 2016, question number 36. So we have to find the dimensions of drag coefficient, mass transfer coefficient, viscosity and mass flux. So first let us consider the drag coefficient. So this is basically the ratio of drag force divided by half into density into area on which the drag force is applied. So I will write what are these. This is the drag force. So this rho is the density of fluid. This A is the area on which drag force is applied. And this U is the stream velocity. Okay, so what is the unit of drag force? Ft. So as it is force, we know force, the dimensions of force is mass into acceleration, so kg meter per second square divided by half into density, we know kg per meter cube, into area, that is meter square, into velocity squared, that is meter square per second square. So this and this gets cancelled, kg and kg gets cancelled, and here also meter cube and here meter, so this all will get cancelled. So this is dimensionless. So the dimension will be m0, l0, t0. So this one. Okay, so now let's consider the mass transfer coefficient. So we can write the equation. Suppose mass transfer rate of A is equal to so this is the mass transfer rate of A, that we can write atoms per second. So this D is the diffusivity, A is the area through which the mass transfer is occurring, and these are the two compositions, Ca1 and Ca2, and this is the distance over which the mass transfer is occurring. So we can write it this way. So this is our mass transfer coefficient. So what is this? This is basically d by x2 minus x1. So we have to find the dimensions of this d by x2 minus x1. So first we have to find out the units of d, diffusivity. So we know that j equal to minus d dc by dx. So what is J? J is basically, the units of J are atoms per meter square per second, equal to minus D. DC, that is basically concentration, so that is atoms per meter cube, divided by dx, that is this distance, meters. So solving this, we get the units of D is meter square per second. So now I will just put this D value here. So what will be the units of mass transfer coefficient? That is D by x2 minus x1 is equal to meter square per second divided by, this is just x2 minus x1, that is basically distance, so meters. So this becomes meter per second. So that means m0 L1 T minus 1. This one. Okay. So now let us consider viscosity. So I will write it here. Viscosity. So that is basically, we know tau is equal to mu du by dx. This is the shear stress, this is the viscosity, and this is the velocity, and this is the distance. So what is the unit of this tau? That is Newton per meter square, equal to mu into du, that is basically velocity, so meter per second divided by meter. So we know that Newton is the unit of force, that is basically kg into meter per second square divided by meter square per second. So this is our Newton. So what do we get? Kg per meter into second. So that means the dimensions will be m L minus 1 T minus 1. This is the dimensions of viscosity. So this one. And for mass flux, we already know this one. This is the mass flux, that is atoms per meter square per second. So we can consider atoms, or we can also consider like kg, the weight of the material that is going through the surface. So the units of this will be, so I will write it in this side. Kg per meter square per second. So the dimensions will be m, that is for mass, L minus 2 T minus 1. So this 2. So the final answer will be A. Thank you.